Okay, this is our last topic for the lesson in Unit 3.2, where we are learning everything we can about linear functions. Now, we have a situation, a real life situation. The first thing we need to determine for this situation is whether it's going to be or we can represent it using it's represented from a linear or a nonlinear function, whether the situation represented here is going to be that. Also, we need to describe the domain. What is the domain? Find the domain of this function, and then find the range as well. We're going to describe or determine whether that domain is discrete or continuous. And at the end of the exercise, we're going to graph the function using that domain. Of course, we need to find out or figure out the range as well. But let's continue. So this is a situation where we have a cereal bar. It contains 130 calories. Now, the number of calories consumed, in this case, calories are going to be represented by the letter C. This is going to be one of the variables. Is a function of. Once we read that, we know that calories is the dependent variable, and that depends on the number of bars, or the number B of bars eaten. That is our situation. So let's first determine whether this is linear or not. And I have made this table to help us represent the situation. As you can see, the input, which is the bars, and the range, or sorry, the outputs is the number of calories that you are consuming, or the number of calories contained in a cereal bar. Here we have 0 means no bars, means no calories. 1 bar, 130 calories. 2 bars, 260 calories. 3 bars, 390 calories. 4 bars, 520 calories. Now, please notice something. As you see, the values of B have or increase by 1 every time. And every time the values of B increase by 1, the values of C, or the output, increase by 130. That means that the rate of change is constant. It means that the situation represented here is a linear function. That's it. Now, we just had it. Linear. Now, let's talk about the domain. Find it. What is the domain of the function? The domain of the function in this case represents all the x values, the independent variable, which in this case is the number of bars you eat. Now, you can eat any value that is greater than 0. It can be 0, so greater than or equal to 0. Now the question is, can I eat half a bar, a quarter of a bar, a third of a bar? Definitely. That means that it's indicated that if you go from 0 bars to 1 bar, there is also values in between, right? So here I can eat half a bar, definitely. So it means that this is not going to be a discrete domain. It's actually going to be a continuous domain, but keep in mind that this cannot be less than 0, because you cannot eat negative number of bars. The domain is continuous and it's greater than or equal to 0. So we have already answered part B. Now we're going to graph the function using its domain. Let's keep in mind that we have our table here of values, the table of inputs and outputs here. When you put them together, remember, you get this. 0, 0 representing x and y, remember? 1, 130, 2, 260, and so on. Once you have all those, which actually it goes from 0 to 4, but you could keep going, right? So as you can see, there are 5 coordinate pairs that can be represented in the graph we have on your right. Okay, so I'm going to use a different color here. So we begin with 0, 0. Then you go with 1, 130, which goes somewhere over here. Then 2, 260, like this, and so on. 3, 390. And now you get this, right? Can you see that they are kind of like lining up? Uh, Assuming we're going to have some sort of straight line, okay? Let's use the green, and sorry, but it's not going to be a perfect thing. And actually, I need to erase this because you know that it cannot go anywhere beyond that point, okay? That's also important. So that's where it goes. And this arrow here, tip, indicates that it just keeps going up and so on, okay? So we plotted the order pairs, we drew the line through the points. The line should start at 0, 0 and continue to the right. That arrow is indicating that the line continues without n as it is shown. And the domain, as you can see, it's continuous. So the graph is a line with a domain of b greater than or equal to 0. And that's it. We're done with this exercise, and we're done with lesson 3.2.